Hi everyone, this is Mrs. Snowbeck. Today we are going to do Unit 7, Lesson 4, and it's all about inscribed angles. So an inscribed angle is an angle with a vertex on the circle and the sides are chords of the circle. And you can see the red angle drawn on the circle over here. An example of an inscribed angle would be angle QRS. Angle QRS is called an inscribed angle because its vertex is right on the circle. And this arc that it opens up to over here, you can see this angle opens up to this arc. Arc QS is called the intercepted arc. So an example of the intercepted arc would be arc QS. Remember, you write the two letters and then you put the curve above it. Here's a few examples of what inscribed angles could look like. Again, just notice the vertex is right on the circle. All three of these examples, the corner of the angle or the vertex is right on the circle. Those are called inscribed angles. Now I want you to think about what we learned previously. Previously, we were talking about angles that maybe looked like this. This is not an inscribed angle. Can you remember what kind of angle this is? Well, its vertex is right at the center of a circle. That is a central angle. And remember, if the central angle is 80, then that arc, intercepted arc out there is also 80 degrees. Well, what we're going to learn today is if we have an inscribed angle that opens up to that same arc, for instance, this red angle down here, that angle is not 80 degrees, it's actually 40 degrees. It's going to be half of the intercepted arc. So we have to keep straight central angles and inscribed angles. Central angles have the same measure as the arc. Inscribed angles have half the measure of the arc. So if you look over here to the right in the box, if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of the intercepted arc. And if we use this drawing down here, we could say the measure of angle 1 equals the measure of arc AB divided by 2. So you take whatever this arc is and divide it by 2 to get that angle. Number 1, find the measure of angle P. Here's angle P, and notice it opens up to an arc that is 70 degrees, arc MN. So since it's an inscribed angle, its vertex is right on the circle. To find that angle, we take the arc and divide by 2. 70 divided by 2 should be 35 degrees. Next, let's find the measure of arc PQ. So arc PQ is here. Whoops, we have to make that into a Q. It looks kind of like an O. And notice that this angle, this 56 degree angle here, opens up to that arc. Now the angle should be half of the arc, so we kind of want to work backwards and we're going to multiply by 2, which turns out to be 112 degrees for arc PQ. Will you please pause the video and try numbers 3 and 4? So number 3, we have to find the measure of angle C. Angle C opens up to the 98 degree angle. And so angle C, since it's right on the circle, it's an inscribed angle, it should be half of 98. 98 divided by 2, 49. Next, if you want to find the measure of arc CF, notice CF is down here. Can you find an angle that opens up to that arc? Yes, the 40 degree angle opens up to that arc. The angle is half of the arc, so working in reverse, we're going to multiply by 2. Turns out to be 80 degrees for the measure of that arc. If two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. Let's start by drawing an inscribed angle. Everybody go in this circle and draw an inscribed angle. Its vertex has to be right on the circle. Let's call that angle 1. Now we're going to draw a second inscribed angle, but it needs to open up to the same arc. So for instance, like this. It's an inscribed angle. Its vertex is right on the circle, but it opens up to that same arc over there. Here's the arc over here. And let's call that angle 2. So since both of these angles open up to the same arc, they're both half of that arc, which means they have to be congruent to each other. So angle 1 will be congruent to angle 2 since they both open up to the same arc. Let's try number 5. It says find the measure of angle T. I notice angle T opens up to arc SV. I also notice angle U opens up to that same arc SV. And so what that means is these two angles must be congruent to each other because they both have to be half of that arc. So 3x minus 5 should equal 2x plus 15. They will be congruent in size. Go ahead and solve. So subtract your 2x, add your 5. X equals 20. Is that our final answer? No, it is not our final answer. We have to plug it in and find the measure of angle T. So the measure of angle T is going to be 3 times 20 minus 5, which 60 minus 5, I think that's 55 degrees is the measure of angle T. Angle U would have that same measure, by the way. Number 6, using the same picture above, if angle S is 3x and angle V is x plus 16, find the measure of angle S. Well, I'm just going to erase a little bit here. Look at angle S and V. Angle S is here, angle V is here. Angle S opens up to arc TU. Does angle V open up to the same arc? It does. So therefore, they must be equal. So 3x and x plus 16, you can set those equal to each other and solve. Looks like x equals 8. They want us to find the measure of angle S, so you're going to have to plug that back in. So think about where do you plug it in. The measure of angle S is going to be 3 times 8, which is 24 degrees. An inscribed angle of a triangle intercepts a diameter or a semicircle if and only if the angle is a right angle. Let's think about angle G. Do you notice angle G is an inscribed angle? Its vertex is on the circle. Look at what it opens up to. The arc that it opens up to right here is a semicircle. And semicircles are 180 degrees. So if you take 180 and divide it in half, you get 90, which means this angle must be a right angle. So let's just make a note here. Segment FH equals a diameter, or is a diameter. This distance across here is a diameter, and that means the measure of angle G equals 90 degrees. Number 7, find the measure of angle F. Well, if you notice angle F opens up to this arc over here, so it should be half of that arc. The problem is we don't know anything about that arc, so that's not really going to help us in this case. But what I do notice is angle G. Angle G opens up to a semicircle. This is a semicircle, which is 180. Therefore, angle G is half of 180, or 90. Now, if you look at the triangle, I have a triangle in here, and it's a right triangle. And the corners of every triangle, every time, the angles add up to 180. So I'm going to take this angle, and the 90, and I'm going to add all three of them together. So 4x plus 2 plus the 9x minus 3 plus the 90, all three corners together should equal 180 degrees because every triangle, the angles have a sum of 180. Now do your normal algebra. So if you combine your like terms, it looks like we have 13x. And I think if you combine all the numbers, we get 89. Subtract your 89. You get 13x equals 91. And surprisingly, I think this might be a nice number. You should get 7. Is that our final answer? No. We need the measure of angle F, so we're going to have to plug in our 7 up here. So the measure of angle F is going to be 4 times 7 plus 2, which is 30 degrees. And that is our final answer. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So I want you to think about this angle right here, angle K. Angle K opens up to this part of the circle, and it's going to be half of that. Angle M across from it opens up to the rest of the circle. A whole circle is 360. So these two angles combined should be half of 360, which is 180. So that's what it's saying here, that if you have opposite angles in an inscribed quadrilateral, that those two angles will be supplementary. So the measure of angle M plus the measure of angle K, those two will add up to 180. Same with the other two, the measure of angle L plus the measure of angle N will equal 180. Number 8, find the measure of angle A and the measure of angle B. So we're going to do this in two separate problems. Let's start with angle A first. One thing I notice is that yellow jewel is a quadrilateral, and it is inscribed inside the circle. So it touches here and here and here and here. The four corners of the quadrilateral touch the circle, and we just learned a little rule that says opposite angles of an inscribed quadrilateral in a circle are supplementary. And you notice how angle C is 90 degrees? Well, that means angle A also has to be 90 degrees because the measure of angle A is going to be 180 minus angle C, which is 90, and that leaves 90 degrees. So that we know. Angle B is a little trickier. So for angle B, notice angle B is here. It is across from angle D. Those two must add up to 180 also. But instead of setting it up like I did last time, I'm going to make an equation. I'm going to say the 2x minus 30 plus the x, the 2x minus 30 from angle B plus the x from angle D, those together will add up to 180. Go ahead and just use normal algebra. So you're going to have 3x minus 30 equals 180. Add your 30. You wind up with 3x equals 210 and divide by 3. X equals 70, but that's not our final answer. To get our final answer, we need the measure of angle B. So take your 70, plug it in. So the measure of angle B is going to be 2 times 70 minus 30, which is 140 minus 30. So I think that is 110 degrees. Go ahead and pause the video and try number 9. So again, we have a quadrilateral WXYZ, and it is inscribed in the circle. So opposite angles are supplementary. So W and Y should add up to 180. So the measure of angle y, you're just going to do 180 minus 95. I think there's 85 left for angle y. So 85 is there. And then a very similar problem for x. To get x, you have to think about the angle across from it. So 60 is z, and then z and x have to add up to 180. So the measure of angle x is going to be 180 minus 60, or 120. That concludes Unit 7, Lesson 4, so please give the practice a try. Let me know if you have questions. Have a good one.